All right, let's wrap up this information from section 3.3. Let's recall what we did on the last video. We were showing how the remainder theorem works. And remember, the remainder theorem says when you divide by a value in this box, the remainder is actually the function value for that polynomial. Now, when the remainder is 0, you have scored, because a remainder of 0 tells you that the number in the box is a 0 of the polynomial function. Yippee, because those are hard to find. And that leads us to the factor theorem. When the remainder is 0, you have found a 0 or a factor. So let's use the factor theorem. Okay, I want to find all the solutions to this equation here. Let me go back to my blue. Okay, well, the fact that it's a degree of 3 says I'm going to have 3 solutions. They are giving me a head start. They're saying that -2 is a 0 of the function f of x equal to that equation. Remember, equations have solutions. Functions have zeros. But they're all found the same way. So I want to find the 3 solutions to this equation, knowing that -2 is a 0 of that polynomial function. Well, if -2 is a 0 of that polynomial function, that means -2 is a solution to that equation. So they've given me a place to start. They're saying -2 is a solution. So here is how we're going to go about using this factor theorem. I'm going to divide by the number they give me, -2. I'm going to list my coefficients. It's in descending powers. Make sure 3, 2, 1 constant. Yep, we're good. And the number that they're giving me, -2, is the one that goes in the box. So our goal is to see if we get a remainder of 0. Let's check it out. -2 times 2 is a -4. Add that to a -3 and we get a -7. -2 times -7 is a +14. Combine that with the -11 and I get a 3. And -2 times 3 is a -6. And guess what? That gives me a remainder of 0. Awesome. What that tells me is this. This tells me that -2 is a solution. Also tells me that -2 is a 0. We were looking at a function. And it also tells me that x plus 2 is a factor. Remember that relationship between solutions and zeros and factors? The number in the factor is opposite from the 0. Because if you plug a -2 right there, you get 0. So they have to have opposite signs. Now let's see how that's going to help us. I divided by -2. This was originally a cubic polynomial, and remember, when you divide, it decreases that degree by 1. So that's a cube. That means this result's going to start off with an x squared, then it's going to have an x, then it's going to have the constant. So this turns into a quadratic. 2x squared minus 7x plus 3, which means this one has 2 solutions. Remember, there's a total of 3. We're given that -2 as a solution. We've got it down to a quadratic. And if I set that quadratic equals 0, I can find my other 2 solutions. And I'm going to try and factor it. But remember, if you have trouble factoring, for a quadratic, you can always use the quadratic formula. But I'm going to factor it because I know I set this one up to factor. So to get a 2x squared, I'll multiply a 2x and an x. And to get a 3, I'm going to multiply a 1 and a 3. That's a 1x, that's a 6x, and if both of those are negative, they'll add to a negative 7. And this will multiply to a positive 3. So look at where I am. 1 0 of a negative 2, or one solution. The other two solutions will come from these guys. Set them both to 0. Here, when I bring the 1 over and divide by 2, I get a half. And here, when I bring the 1 over, I get a positive 1. So let's look at what we now know about this problem. We know, and let me just do this, and let's just review everything that we know about this. I think I want pink, just in that kind of mood. All right, here is what we know. We know that x equal negative 2, a 1/2, and a 1 are all solutions. They're solutions to the equation here. We also know that x equal negative 2, 1/2, and 1 are zeros of the function. And finally, we know the factors. I've got a factor of x plus 2 from that 0. I can call this factor x minus 1/2, or it could be 2x minus 1, same thing. And this 0 gives me a factor of x minus 1. So when you hit a remainder of 0, you hit the jackpot. Because you found zeros, you found solutions, you can also determine factors. So I would like you to try this next one. We want to show that x minus 3 and x plus 3 are factors of this polynomial, and we want to use the result to find the remaining factors. Actually, this should not be there. So the degree is 4, so I would be looking for 4 zeros, or 4 factors, or 4 solutions, because they're all basically saying the same thing. When you do this, though, the number in the box, since they're giving me a factor, the number in the box is going to have to change signs. Also, when you do this, you're going to have to do repeated synthetic division. What do I mean by that? Well, repeated synthetic means once you complete this synthetic division, you're going to get a remainder of 0. You start the next synthetic division off of this answer. Because what that's going to do is it's going to get you down to a quadratic. See if you can do that, pause it, and then come back and check. So here's the result of the first synthetic division. We get a remainder of 0. Now use that result to do your second synthetic division. And since we're dividing by x plus 3, we need to take the opposite sign in our box. Okay, the result of the second synthetic division is a remainder of 0. Whoops, that should have been a negative 7, and that should have been a positive 21 to get a remainder of 0. Whoops, caught that mistake. All right, so that means that 3 is a 0, or x minus 3 is a factor because of that. This tells me negative 3 is a 0, or x plus 3 is a factor, again, because I got a remainder of 0. This was a degree of 4, and I divided twice. When I divided once, that brought it down to a cube. When I divided that cube by the next one, that reduced it to a square. So I am left with the quadratic x squared plus 3x minus 7. And when you're down to a quadratic, you can either factor or use the quadratic formula. Unfortunately, this one doesn't factor, so I want you to practice using the quadratic formula. Remember, we're looking for 4 factors, or 4 zeros. We've got 2. We're going to find the other 2 from this. So use the quadratic formula. When I use the quadratic formula with the coefficient a being 1, b being positive 3, and c being negative 7, I end up with a negative 3 plus or minus the square root of 37 all over 2. And I can break that up into 2 individual values, negative 3 plus the square root of 37 over 2, and a negative 3 minus the square root of 37 over 2. So I've got 4 zeros. 1, 2, 3, 4. The degree was 4. And if I wanted to, I could write all of those out as factors. So let's look at the last thing. Let's describe the error in this synthetic division problem if I were to divide x squared plus 3x minus 5 by an x plus 1. Is it in descending powers? It is. 2, 1, constant. So then I would have a 1, a 3, and a negative 5. What number goes in the box? Since I'm dividing by x plus 1, what should go in the box? There's the mistake. Should be a negative 1. Remember, when you're dividing by this binomial, you have to do the opposite sign. So there is the mistake. And that will finish this up for section 3.3. Please let me know if you have any questions. I am happy to help.